Okay, this is our environmental science and how chemical engineers can solve the issues within carbon emissions and the environment, as well as using alternative energies.
Environmental changes. Now, this is a highly debated topic. This topic comes up whether you're with your friends or your family or even colleagues. Everyone has their say in this matter. But as future chemical engineers, it's important that we are well informed and knowledgeable about our part in the environment. And as humans, it is important that we are aware of the impact that we are making across the world. The environmental changes we've seen in the last century has been more on the negative side. As civilization has developed, emissions and pollutions have increased worldwide. This is important to be aware of and fix as chemical engineers. We'll do next slide. Now, the causes and effects of pollution and in the environment. There are many opinions on this matter. There may never be a right answer about this, but there are topics that are very important and are increasingly showing signs, such as global warming. Now, this issue has been denied for many years, but as our technology advances, we see that global warming is a scientific fact. We see this as our emissions increase with carbon dioxide and methane into the environment. In result, this increases temperature in our lower atmosphere as carbon captures heat more than our oxygen and nitrogen atmosphere. It's important that we are aware of this and reduce this. Additionally, we have CFCs, which are chlorofluorocarbons. These have been an issue since around the 1930s, and these come from many sources such as AC units, refrigeration, blowing agents, foams, insulation, packing materials, etc. Now, these CFCs destroy our Earth's ozone layer, and in addition to that, it also increases our greenhouse gases, thus additionally warming the atmosphere on top of our already existing CO2 and methane pollution. Next slide, please. Now, why is this important? As I've stated, it's important that we are aware of this going further. As these emissions increase and as population increases, we will see an exponential growth of these emissions and global warming. This is very dangerous going forward, as the Earth may not sustain population in the next few hundred years if we do not attack this immediately. Now, this also includes the problem of advanced civilization versus less fortunate civilization, in terms of our emissions have created problems to the point where underdeveloped countries have all of these regulations placed on them, and only countries with money will be able to satisfy these regulations and add all of these pricey solutions to reducing these emissions. This affects the Earth, people, and ethically is a very important topic that needs to be fixed. Now, as chemical engineers, this is our importance to society and the environment. it is essential that we do not jeopardize our civilization. Next slide, please. Now, how we counteract climate change with alternative energy sources. As we are going forward, we need to be aware of these carbon emissions. And by reducing these, we can either put more regulations and remove these from the existing plants or create alternative energy sources. Now, this could be done with solar power and nuclear power, which John will get into later, or wind power, as we have now. Now, it's important that we localize these power productions, and this will attack the problems that we face now with our bigger plants and which produce large amounts of pollution. It is very important that we keep people working on this problem and continue to reduce this pollution. Next slide, please. Now, to sum this all up, how are the chemical engineers solving all of these issues? So, pollution combating is the chemical engineers' environmental route. Now, they help the toxicity in the water and the air and the soil. Now, these pollutions in previous slides have been explained. Many of these CFCs, methane, CO2, sequester into the water. And this is very dangerous. It is our job to remove these, as well as the air, and which I talked about earlier, and as well as the soil, which will damage crops and food production. That's also important that we regulate the pollution from the plants, vehicles, and more, which I explained as the methane and CO2. And it's important that we recycle these waste products and reuse these materials instead of releasing them into the environment where they are harmful instead of useful.
And I'd like to go into how the alternative energies for preventing a lot of the carbon emissions from energy, and one of them is nuclear. It's the most dense and efficient form of energy production, and it is constantly developing technology, and there's a large media blackout on how useful it is, and in terms of what it's actually capable of. People are just scared of it. For example, much of our uranium, even though people make uranium seem to be highly dangerous and pollutive and long lasting, and how long it can take in order for it to cease emitting, it can actually be recycled into thorium. And thorium is another radioactive energy producing particle, but it is much less radioactive, and therefore it itself can be used for nuclear, but it does not have the capability for large scale meltdowns and is much less dangerous. But uranium itself can also be re-enriched so that it can be used again, but at a lesser potency. Another developing technology is pebble bed reactors. And this is different from the traditional large rods that are used, in that these pebble beds are made of about grapefruit sized miniature pellets, and these pellets, all of them individually, are incapable of overheating and melting down, making disasters genuinely impossible. And China is actually leading in this technology, and they were one of the first to develop it. It's much safer for disposal, as it has several layers that prevent the nuclear material from the inside from ever leaking out. in breaking out of the shell. As you can see, this is a diagram of a single pebble from a pebble bed. And underneath of it, you can see how a pebble bed reactor works as opposed to the aforementioned large rods that are dipped in and out of solution. And these can be made out of U-235 or thorium. And America has high potential in this area because America has a lot of nuclear reserves as it sits on. And uranium, and like I said, uranium could be re-enriched. It's highly recyclable. But there's also solar, and even though solar is much less efficient than nuclear, it's still a much more media friendly, and people are much more accepting to it. And there's a large switch to it anyways. But here in Florida, about 15 miles south of my hometown, there is Babcock Ranch, and it is going to be America's first solar powered grid positive town, in that it will be able to exceed its own need for its energy from the solar it produces. And from this, it will sell back to local counties and towns, as well as FP&L, the energy that it creates and does not use. But it also has backup systems for storing energy to keep the town supplied in the case of event that large maintenance is needed or natural disaster. This town also addresses the concern that solar occupies a lot of space, in that it otherwise would take away from the local environment. And this is addressed in a lot of the town's agenda, in that there is very clear dictation between what is nature green spaces and what is solar space for the community, and what is viable land for expansion. Chemical engineering has a lot of solutions for these for energy crises, and they all stray away from using carbon emitting. And for solar, there are more efficient solar materials that are being developed that go against the 23% efficiency, in that a lot of solar is highly subjected to weather conditions and climate. But more efficient panel materials are being developed. And the drawback is that some of these materials are more susceptible to breaking down over time, or are not as reliable. But chemical engineers, while they developed it, are also developing solutions to this, as well as they are finding different forms of these materials that are more internally stable and less susceptible to erosion from oxygen and rain and etc. And with nuclear has the highest energy producing, low carbon emitting energy source available currently. And it is carbon free and produces twice as much energy as any other carbon free source, such as renewable, as solar and water or wind. And just to give an idea of how energy dense uranium is, one pellet of uranium that is equivalent to the size of about a gummy bear, like your thumb's fingernail, it creates equivalent energy to 1 ton of coal, 149 gallons of oil, or 17,000 cubic feet of natural gas. And it creates no byproducts of nitrogen oxide or harmful greenhouse gases or particulates in the air, or heavy metals. These are our references, and that concludes our presentation on how chemical engineers can solve energy crises and environmental issues.